Hello, my name is Nixon Anthony, and I'm from Group 6 for the automation project BTE 3262. The topic of my project is smart exhaust fan using MCP 9700. Alright, so let's go to the introduction. So, for my project, the introduction is an electrical appliances, when not in use, left with a switch open, can cause various problems based on the appliance function. Implementing the uses of an Arduino not only can create a complete functioning circuit, but it also can control or initiate a program based on the user desired instruction. Therefore, in the near future, Arduino can be found on almost every technology around us. So, for the project background, for some practical reason, some electrical appliances are unable to move automatically without operating it manually. Therefore, an Arduino emerged as an intermediate devices to solve this problem. Arduino Uno is a microcontroller board based on the Atmega 328P at the datasheet. It contains everything needed to support the microcontroller. Simply connect it to a computer with a USB cable or power it with a AC to DC adapter or battery to get started. The Uno board and version 1.0 of the Arduino software IDE were the references versions of Arduino, which have since been replaced by newer releases. Arduino can be programmed by the user to control output based on the input received. Okay, so for the problem statement, some exhaust fans are left open even though they are not in use. If a person or family install several exhaust fans in their houses without knowing when they last used, this can cause their usage of electricity increase. So a smart control system is needed, such as Arduino, to control the exhaust fan with only sensor. Second, the design using an Arduino require a basic knowledge in C++. We already learned basic programming during lecture session thanks to our lecture, but some of the code cannot be read or identified by the Arduino software. Using a code from the Arduino library can help with this problem. So this is the project objective and scope. So for my objective, designing a project that meet the requirement needed, implement the uses of Arduino system in the project, achieving an output result based on the system design, and also using switches or sensor as an input. For the scope, output can be handled by the simulation, using Arduino to control the process of the circuit, limited component based on the simulation software used, and also using a specific software to design the simulation circuit. So this is the flowchart for my project. So as you can see, first it will go here, start. The sensor that we use is the temperature sensor, MCP9700. This sensor detects the temperature surrounding, and it will send the signal to Arduino Uno. So it will give different output based on the temperature received. If the temperature received is 0 until 25, the motor duty cycle will be 0%. But if the temperature received 26 until 40 or 41 until 60, the motor duty cycle will be around 30% or 55%. If the temperature received is 61%, temperature received is 61 until 80 Celsius, the motor duty cycle will be 75%. But if the temperature is 81 until 100 Celsius, the motor duty cycle will be 100%. And after the motor duty cycle is set based on the temperature, it will go to the relay. The relay is we set for timer 1 second. Each of these will receive have their own relay, and will go to the LED. If the motor is 0% duty cycle, it will go to the relay. It have 1 second delay, and after that it will go to this blue LED on. But if the motor is 30% or 55% duty cycle, it will go to the relay, and after that, after the 1 second delay, it will go to the green LED on status. But if the motor is 75% duty cycle, it will go to the relay. The relay will have delay 1 second also, and it will go to the yellow LED on. But if the motor is 100% duty cycle, it will go to the relay that have delay 1 second, and it will go to the process red LED on, and it will trigger the 9-volt buzzer alarm because the temperature is at its peak, that is 81 until 100 degrees Celsius. So this is the Gantt chart for my project. The activities is the project plan. I planned it for week 11, and I did it at week 11, the actual plan. For the project research, I planned at week 11 and 12, but I actually did at week 12 because week 11 I have many assignments to do. That's why I started the project research at week 12. So for the writing programming language, I planned at week 12 and 13, and I done it. And the actual thing I do at week 12 and 13 also. And the circuit design I plan to do at week 12 and 13, but I do at week 13 because the programming language I took 2 weeks to do the actual program. And the simulation test also do at week 13 because we cannot do simulation test until the circuit design is completed. And the report development is done at week 14. So this is the list of components. The component we use is MCP9700 temperature sensor. The reason we use is to detect the surrounding temperature, and also Arduino to program and control the circuit. Relay we use as a timer and switch for the LED. And the LED is used for as the temperature indicator. And for the motor, we use for the exhaust fan motor. The L293D we use as a motor driver, and the buzzer we use as an alarm for the project. So we can see the MCP9700 temperature sensor. This is the sensor that we use for the project, and the feature is it is a tiny analog temperature sensor, and the temperature measurement range is minus 40 Celsius to 125 Celsius. The typical application for this sensor is that it is used for hard disk drive and other PC peripherals, entertainment system, home appliance, office equipment, battery packs, and portable equipment, and also for general purpose temperature monitoring. And this is my circuit design. This is the MCP9700, the Arduino, the L293D, the motor driver, and also this is the motor for the exhaust fan 1 and exhaust fan 2. And this is the relay 1, 2, 3, and 4. It comes from the pin 9, 10, 11, and 12 for the output. And also this is the LED indicator for the temperature. The last LED will connect to the buzzer, and the buzzer will produce a noise indicating that it is an alarm that indicates the temperature is already at its max, that is 81 degrees Celsius until 100 degrees Celsius. And this is the program Arduino. This is the code for the Arduino. I declare the pin 3, 4, 5, 12, 11, 10, 9 as output for my Arduino Uno. And this is the if-else statement for the temperature. And this is the formula that I use for the temperature to convert from the analog value to decimal value so that the temperature that is shown on display is accurate as the temperature sensor MCP9700. And this is the circuit simulation for the temperature from 0 to 25 Celsius. It is 0% duty cycle and the blue LED indicator is on. And this is the temperature that is 26 Celsius until 40 Celsius. The duty cycle is 30% and the green LED indicator is on. And this is the temperature from 41 until 60 Celsius. It is 55% duty cycle and the green LED is still on. And this is the temperature that is 61 until 80 Celsius. 75% duty cycle and the yellow LED indicator is switched on. If the temperature reach 81 until 100 degrees Celsius, the duty cycle will be at its max, that is 100%, and the red LED will switch on, and also the buzzer alarm will be triggered. The temperature sensor output voltage varies based on the temperature around it. It is used to measure temperature between 0 until 100 Celsius. Convert analog signal to decimal value can easily be done by using the Arduino. A single 293D IC is capable of running 2 DC motor at the same time. The direction of these 2 motor can be controlled independently by the programming Arduino. PWM, pulse width modulation signals, can control the DC motor speed by varying the duty cycle. The maximum duty cycle can be reached until 100%. A relay involves 2 circuits, the energizing circuit and the contact circuit. The coil is on the energizing side and the relay contacts are on the contact side. A timing relay is a simple form of time-based control, allowing the user to open or close the contacts based on a specific timing function. So to conclude, this project is fully functional based on the program made by the Arduino and then tested in the constructed circuit and produced as a simulation. Age of a relay timer is set to 1 second delay to switch between the temperature range set in the program. This is to avoid sudden change in LED when the temperature indicator move 1 Celsius up and down between the range of another temperature. We can improve this project by adding HC SR04 ultrasonic sensor, which act as a detector whenever a human is within range, 100 centimeter or not. So this is the Arduino. We will verify first. After the Arduino have done compile, we take this code, the .hex code, and we will bring to the simulation at Proteus. Double click on the Arduino, we go to the program file directory and we paste the compiled Arduino code that we get from the Arduino Uno. Click OK. Then we run the simulation. As you can see that at 25 degrees Celsius, the virtual terminal indicate 25.68. That means it's around 25 Celsius. the LED blue is switched on. So we see the presentation just now. It's 0 until 25, 0% duty cycle, blue LED on. So for the next range is 26 until 40, 30% duty cycle. So if I switch to 26%, it will go to 30% duty cycle, and the exhaust fan will start moving. And also the LED green indicator is switched on. So we set until 41 Celsius. As we can see, the virtual terminal number is also changed based on the temperature, MCP9700 that we changed. So we can see that from 40 to 41, the duty cycle have changed. That is 55% duty cycle, but the green LED indicator is still on. So for the next range, 61 until 80 Celsius, the duty cycle should be 75%. So we switch to 61%, 61, not 61%, I mean 61 Celsius. When the temperature has reached 61 Celsius, the duty cycle will go to 75%. And also the exhaust fan will start moving a little bit faster than before. And the LED indicator yellow is switched on. But when the temperature has reached 81%, not 81%, 81 Celsius. Sorry, I mistake again. The LED will indicate red, and also the buzzer will trigger. You can hear the sound, meaning that the temperature has reached its max. So whenever the temperature is reached 81 until 100 range, the buzzer will trigger, and also the red LED will trigger. And we have 1 second delay between the switch because we set the timer relay 1 second. We can see the timer delay here. Switching time, I put 1, so that the delay between switching for the temperature range is 1 second. So that's all from me. Thank you.